All right, so we are doing lesson six, session two. I'm just going to go over for our warm up some of the different place values here on this table. As you see here, we've got all the different place values that we'll use as fifth graders. And the dots here, of course, represent a decimal point. But I just want to use this table to kind of illustrate how these numbers are different, are connected by different place values. So let me put a six here in the ones place. Oh, before I do that, let me do this. So any numbers to the right of the decimal are the tenths, the hundredths, and the thousands. Any numbers to the left of the decimal start with the ones, tens, hundreds, and thousands. So there's your basics for that. Anyway, here's an example. I'll put a six here in the ones place. So the connection between all these different place values is they increase or decrease by 10. So for example, I have six ones. If I move it one place to the left, that's going to become a 60. And if I take that 60 and I move it another one more place to the left, that's 60 times 10, which gives us 600. And then if I take that 600 and move it one place to the left, that'll give me 6,000. So again, we're all doing these by multiples of 10. But what happens if I move those six ones to the right? It's a little different. So this will decrease by a power of 10. It'll go from 6 to 6 tenths. Move it one more to the right, that becomes 6 hundredths. And move that 6 hundredths one more place to the right, it becomes 6 thousandths. So again, depending on where it's listed on this table, will determine its value by a power of 10. And that's really what we're going to get into next week as far as talking about powers of 10. Okay, so let's look at your first page here. All right, so go ahead and turn your workbooks to page 125. And what you should see at the top of there is some grids that we're going to fill in with me. Okay. Each decimal grid in models A, B, and C represent one whole. Shade each model to show the decimal number below the model. All right, you could just shade these as I do them, because what gets shaded is what we're going to focus on. All right, so these are, since one grid is one whole, I've got three point here or three whole, so I shade in three of those. Below this one is 3/10, so I'm just going to shade in three groups of 10. And this is 300ths. And since there's 100 squares in here, I'll just shade in one, two, three of those squares. Okay, so we're going to use these grids to kind of model what's happening when we change place value. So underneath here, we can say hundredths. Under here is tenths. And under here is, call these the ones. Okay, so we're going to show the connection between these. So as I said, if you take these 300ths right here and you move it one place value to the left, you notice that 3 became 30 squares, or it went up by 10. And if you have these 30 squares and we go from the tenths place to the ones place, that 30 became 300 because we have 100, 200, 300 here. So again, as you move one place value to the left, you're increasing by 10. But let's take the opposite. If you have three ones and you move over here to the tenths, if you slide it over to the right, you're going to be reducing that by a tenth. And then if you move those 3/10 over to the hundredths, you'll be reducing that by a tenth as well. So again, if you're moving to the left, you're getting bigger when you move your numbers. If you move your numbers to the right, they're getting smaller. So just keep in mind that basic concept. Okay, so for this next one, right below here, so this wants to show us mathematically, do some equations to kind of illustrate what we just talked about. So let's put our 300ths. We moved it to the left, so we multiplied by 10, and that gave us our 3/10. And then we took our 3/10 and multiplied it by 10 to give us three whole, or three ones. And then we moved from the three ones one place to the right, or divide by 10, or we could think of that as the 1/10. That gave us 3/10, and then we take 3/10 and moved it one more spot to the right. That gave us 3/100. Don't forget my 0. Okay. And looking at the bottom of the page, all right, finding that 1/10 of a number is the same as multiplying by a number by um, 1/10. So I kind of illustrated that with our first example. And that's why I used that instead of the dividing by 10. Anyway, so we have 3/100 is 1/10 of, so it's one step away from 3/10, and that can be simply put as 0.03 equals, again, since 1/10 equals, that's the same thing. We'll put 1/10 times 3/10 will give us 3/100. For this one, we know that this blank number, this number is 1/10 of 3. Well, since I know that's one place away from them, let's put that in as our 3/10. And 3/10 equals 1/10 times 3. Okay. Again, these equations are just to show if you're converting between different place values, it's just going to be a power of 10. All right, turn the page, and let's look at number lines. So this is kind of interesting how this works too. So we talked about grids first. Now we're talking about number lines. Let's fill out the number lines first before we get into anything, because the wording on a couple of these is kind of tricky. So I'll just kind of show you what they mean. Fill in the missing labels for the red tick marks. The tick marks are these little lines right here on the lines below. All right, well, let's look at the red, and I'll write them in. So since we've got every line on here is in tenths, so this is 2/10, 5/10, 6/10, and 8/10. Every line on this third line, actually, I'm going to put this ones, tenths, and these are hundreds. So all of these on the third line are hundreds. So put that. That's why we got that second digit there to represent the hundreds place. And over here, let's put 1.00. Okay. Place a point for the whole number 1 on the first number line. And I guess I'll do that. And then put a 1 for the decimal 1/10. And then another one for 1/100th. Okay, so I'm going to keep this up here, and let's talk about number 5, which is below. This is a pretty confusing question, so I don't like using it because I think kids will miss the point if it does it the way it wants me to. So let me just explain what's happening here. With those grids, every time you always moved in groups of like either increased by 10, like a multiple of 10, or times 10, or they decreased by 10. Number lines do the same thing, because if you notice, this whole line right here is one whole. This is our ones. When we move down to the tenths, notice we broke this down into to 10 lines. And then when you took a tenth and then you broke it down here into hundreds, you broke it down in 10 lines. So basically, with a number line, as you get to as you move move place values like ones to tenths to hundreds, you just increase the lines down here below. So that's why it keeps doing that. And It's also, this is just like, um, it's just like a ruler or meter stick. If you notice that those are broken down into smaller and smaller lines to represent basically different measurements, or place values. So keep that in mind for this one. So cross out 5. Um, doesn't help us understand it there. But okay, so here's where I kind of bring everything together for the lesson here. Your your grids. It says, how do decimal grids and number lines help you understand the relationship between adjacent, which just means right next to, just to remember what adjacent means in our number system. Um, so for the grids, like we started the lesson with, um, 10 times as many squares as you move from a smaller place value to a bigger place value. And for number line, and we have groups of 10 lines. Again, it will break each little section down into more and more smaller lines or tick marks to kind of help us understand it. So everything for place value is related to that magical number 10. All right, so for this last part, let's put it all together. How many times is great is the value of 1.5 and the value of 15 hundredths. So let me write those down. We got 1.5, and we're comparing it to 15 hundredths. So if you look at 1.5, we're still using the same digits. We're still using um, a 1 and a 5 next to each other. You'll notice that we can tell how much bigger this is because it's one place value. If we shift the 1 and the 5 over one place, that means it is 10 times bigger. Now, what would happen if we had 15 and 0.15? Well, you would move 1, 2 places, and that would be 2 places. That equals 100 times bigger. Basically, a 10 times 10. That's how we figure that stuff out. So, hope that makes sense. Again, we're just trying to understand why place value, why numbers shift, and how much their values shift when you're moving them. Your homework for today will kind of help with that as you work with number lines. You work with decimal number lines. You'll be given a number line that has an unknown value that you're going to have to figure out looking at what the value of the lines are. So you'll mostly be working with the tenths place, and then later on, once you get past 60, I believe or 50 or 60, you'll start working with the hundreds place. So let me know if you have any questions.